Hello, this is a video for me to remind me in the future when and if I forget about how to derive the relationships for cylindrical and spherical coordinates and converting to Cartesian, etc. Okay, I'll start with cylindrical coordinates by drawing the vector components in the Cartesian plane. So here we go. X, Y, and Z. For cylindrical, there's a point. It comes out an angle from the x-axis phi, and it is a distance z up from the origin, and a distance rho out from the origin. Okay, and I need to remember that it goes from x, y, and z, which is more familiar, to the rho phi z coordinates. Okay, so now let's derive the relationships to convert from Cartesian to cylindrical. From the diagram, you can see, or you may be able to see, that rho, you can use pi-fag to get rho, which will give you rho squared is x squared plus y squared, and this implies that rho is equal to the root of x squared plus y squared. Whoop, there you go. And phi, using some simple trig, is just inverse tan of y over x, because it's just in the xy plane, so it's just a 2D thing really. Phi is inverse tan of y over x. And the most simplest of them all is z, which is equal to z. Okay, now to convert from cylindrical to Cartesian. You can see by looking at this diagram, or you may be able to see, that x, let's do x first, is equal to rho cos phi. And then y is rho sin phi, which is also easy to see, and again z is equal to z. Okay, so we've done the conversions for the vector components. Now let's get the unit vectors. Let's draw the ijk plane with the cylindrical rho phi z unit vectors in it. So this is the ijk plane. I, j, k, and then there's a point defined in space by rho phi z. Let's just write that down to remind me. X, Y, Z goes to rho phi z. Okay, so the point is described again by rho phi z. So here's phi, here's Z, and here's rho. So then the Z unit vector will be in this direction, the rho unit vector will be in this direction, and the phi unit vector will be in this direction. They're all perpendicular to each other. Okay, so firstly let's work out the rho unit vector. Well, the rho unit vector is in the ij plane, so it's sort of two-dimensional problem again. And it is the I component of the rho unit vector is rho cos phi I, so no, not rho, so cos phi I, and then sin phi j. Okay, and then for phi, there are two good explanations for phi. Firstly, I'm going to explain it using the physical interpretation of this diagram, or diagrams. I'm going to draw the phi unit vector in the ij plane only. Okay, so let's this is I, this is j. This can be the rho unit vector from the point, and this can be the phi unit vector. And this is phi. It can be seen that this component is of the phi unit vector. No, just this component here is cos phi I, and this component here is sin phi j, but that would describe not the phi unit vector, the rho unit vector. What we want to do is get something perpendicular to that to face in this direction. So a way of thinking about it is to imagine that it's on a hinge here, and it's rotated like so, 90 degrees. And if you did that on the page, the sin phi component would end up here in the negative I direction. So write that, negative sin phi I, and the cos phi component would end up here in the j direction. So this would become, not this, it would become cos phi j. And these, when you add them, would result in something going in this direction, which you can see is in the same direction as phi here. So basically we've turned it to be in the right direction. And this would imply that the phi unit vector is cos phi j minus sin phi I, or write it more fully would be cos phi j minus sin phi I. Okay, and possibly a better explanation or way to remember it is that phi unit vector is equal to the partial derivative of the row unit vector with respect to phi. And this implies, if you're looking at rho, which is here, this would differentiate to sine with a minus, and this would differentiate to cos. And as you can see, that would be a cos there, and the j component, yes, minus sine I, yes, correct. So that would imply, again, phi hat equals minus sine phi I plus cos phi j. Okay, one more unit vector remaining, and again the easiest, z is equal to k. I was going to say z, but I think it's k. Okay, next let's do spherical coordinates. Spherical, just to remind me, and also another thing to remind me that we're going from x, y, z to rho theta phi. Well, there it is. Okay, let's draw the vector components in the xyz plane. X, Y, Z. Okay, there's a point here. This is phi, increasing in this direction. This is rho from the center to the point. And this is theta, increasing from the z-axis to the point toward the xy plane. Okay, now let's work out the equations to go from cylindrical to Cartesian values. X, first, well, by looking at the diagram, I can see first I'd have to say rho, sine theta, and then cos phi. Yep, and then y would be rho sine theta and then sine phi. And z would be rho cos theta. So rho cos theta. Okay, they are correct. And now we need the equations to go from Cartesian to spherical. Did I say cylindrical earlier? I meant spherical. Okay. So to get rho, it's kind of like Pythag, but with an extra dimension. So rho squared is equal to x squared plus y squared plus z squared, which implies that rho is equal to the root of x squared plus y squared plus z squared. Okay, next let's get phi. Well, using some trig, phi is in the xy plane only, so it's a sort of a 2D problem again. This is pretty easy. It's inverse tan of y over x. You can remember SOHCAHTOA. Tan is opposite over adjacent, so that will be tan phi is y over x. So then phi is inverse tan of y over x. Okay, and finally theta, using some trig again, is, well, tan is opposite over adjacent, so looking at theta here, opposite is well, this would be, using Pythag, the root of x squared plus y squared, because it's the equivalent of this. And so opposite is root of x squared plus y squared. And adjacent is simply z, so then theta is inverse tan of the root of x squared plus y squared divided by z. And that's correct. So next let's do the spherical unit vectors. Just to remind myself of what I'm doing, I'll write spherical and the axis, the components which are being changed, x, y and z, are going to rho, theta, phi. And let's draw the axis again. Let's draw the spherical unit vectors in the Cartesian plane. So I, j and k. There's a point here. Here is phi. Here is rho, and here is theta. So the unit vector rho will be in this direction, the unit vector theta will be in this direction, and the unit vector phi will be in this direction. Okay, and from the diagram you may be able to see that the rho unit vector is the I component of the rho unit vector is sine theta, gets you there, and then cos phi I. And then the j component would be sine theta again to get you there, and then sine phi to get you there. So plus sine theta sine phi nvj. As I was saying before my phone ran out of memory space for the video, and then the k component of the rho hat unit vector is, looking at this diagram, cos theta k hat. Okay, well that's correct. Again, as with the cylindrical coordinates, there are two explanations to get one of the unit vectors. In this case, it is the theta hat unit vector has two explanations that I can think of that are good. Okay, the first explanation, which is the longest, as was before, you can think, it's very useful to think of this shape. That's meant to be a right angle there. Yeah, that's theta. That's theta. Okay. Right, so if you look at this diagram and compare it to this, you're basically extending this, and you can recover theta in a different position here, which helps you understand the derivation of it. So with this in mind, it can be seen that theta hat is equal to, well, it would be cos theta, which will bring you down to here, and then cos phi I, and then the j component would be cos theta to bring you down to here, and then sin phi j, and then the k component, you can see this is going down, so it's in the negative k hat direction, will be from this diagram, from this diagram, sin theta in the negative k hat direction, so it would be negative sin theta k hat. Whoops, went off the camera there again. Okay, let me just check that. Yeah, that's correct. So the second explanation for this, which you may think is better because it's more concise, theta hat is equal to the partial derivative of the rho hat unit vector with respect to theta. Okay, so you can see that if you look at this and differentiate it with respect to theta partially, sine to cos, don't change the sine to cos, and that will end up with this, yeah. The I component will be the same then. So yeah, as I was saying, the I component will be the same there. And, oh, by the way, the camera ran out of space again, so I've just removed all the things from it and cleared off the space. Anyway, so I was just proving this, or showing it anyway. Differentiate the rho hat unit vector with respect to theta partially. So, theta, sine to cos, don't change the sign because this will become cos theta sine phi in the j hat direction. Cos theta sine phi in j hat, yes, and then this differentiates to minus sine k hat. There you go. Correct. Okay, what's left? Let me have a quick check. Ah yes, so we've done the rho hat unit vector, the theta hat unit vector, Now I've got the phi hat unit vector left in the spherical coordinates, and then that's it. So for the phi hat unit vector, it's in the ij plane. Yeah, it's in the ij plane. This is parallel to the ij plane. So it has no k hat component. And again, you can imagine, to help you, you can imagine this, except now these thetas will be phi's. And it's just the same picture but swizzled in the other direction. So it's the same, except theta is phi. So let's just draw that again. And let's draw it on the same page. So the I hat unit vector there, j hat. This is the theta, the phi hat unit vector. Okay, so from this diagram implies that the phi hat unit vector, which has no k components because it's in the ij plane, is cos phi j and then, well, cos phi j, yeah, and then it's going in this direction, which is opposite direction really to the I, so it's going to need a negative I component, and that would be sine phi, so it would be negative sine phi I. Let me just check that. Cos phi j minus sine phi I, correct. And I think that's it. Let's have a look at that page again. Yes. Okay. So let's just go over the pages which I've done. Okay, well I started with this, cylindrical, and then went to this, and then to do the unit vectors. And then I did spherical, and then the spherical unit vectors, and then that's it. End of recording.